This conference will now be recorded.
Yeah. So we was discussing about functions. We understood regarding function, what is function, how to write a function, and about function return, function parameters, different types of parameters, formal parameters, actual parameters. In the actual parameters, positional parameters, keyword parameters. In formal parameters, positional parameters, those are mandatory parameters, default parameters or optional parameters, variable length parameters, variable length keyword parameters. These things we understood. And also we understood about local variables, global variables. What is local variable? What is global variable? Locals function, globals function, right? And how to operate the global variable. Whenever you want to operate global variable inside the function body, better you specify them as global variables in the global keyword. Just the same, look at this program. V1, V2, both are global variables. These are integer objects. FUNC1 is a function object, FUNC2 is a function object. I'm calling FUNC1. So FUNC1 will be executed here. A, B local, I, J local. V1, V2 I am modifying, but they are not modified. They will be modified locally. Local variables gets created. Locals I printed, globals I printed, right? So function 1 execution over. Then I am calling function 2. So function 2 execution begins. A, B, I, X. These are local. Here, what are the local variables, global variables I am printing, but I, X both are local. But due to this, global variables are not get modified originally. Due to the function 1, global variables are not modified. Actually, they are created local variables. Understand? That we are able to understand here. Same previous kind of program. So if you want to modify the global variables inside the function body, better specify global variables using global keyword. Specify that these are the global variables, so it will be operated them globally. This about local variables and global variables. So here the better thing we have to understand Python program layout, program memory layout, and function stack frames. This understanding is very important. Whenever you begin executing a program, the program execution begins. Memory resources are occupied for the program. This is program memory. So memory resources are occupied for the program. The program memory has its own layout. So this is program memory layout. Mainly the program memory layout available in 4 different segments. There are 4 different segments. One is code segment. One is code segment. All the code objects goes to code segment. Second one is data segments. All the data container objects goes to data segment. Next one is stack segment. Function stack frames information is maintained in the stack segment. Another one is a heap segment, but generally we'll write like this, ES. It is a heap segment. Runtime dynamically created objects goes to heap segment. This is Python program memory layout. Here stack segment is the main thing to allocate memory for the functions. The stack segment area is what allocates memory for the this is stack segment area. Mainly this stack segment maintains stack pointer. It indicates a stack pointer, mainly stack pointer. And another one is instruction pointer. One is a stack pointer. Second one is instruction pointer. Stack pointer is nothing but an identifier, an indicator where the free memory is available. Where the free memory is available to occupy memory for the function. So here is the free memory is available. Here you can occupy memory block, it indicates. First of all, it know the where the stack pointer is indicating. This is the layout. Now let you take any program. Look at this program. Okay, let us see this program. Yeah. Here first program execution begins. First line will be executed. Okay, that is just a print command. Then V1 is the object created. V1 is the object created. 9.8. If you observe carefully, 9.8 is the float object. It is created in the memory. V1 is the reference variable because it is a float object. This is data container object that goes to data segment. So V1 references this object. Okay. The next myFUNC1 is a function object. See, it creates a function object myFUNC1. Of course, this function object has its own internal label, identification label. This function object has its own internal identification label. And the function object is a code object. It performs a functionality. It has its own code of the function. Okay. It has its own memory ID. myFUNC1 is the name of the function. myFUNC1 is the name of the function. So this references the function object. myFUNC1 is the name of the function. This references the function object. Next, another function object is created. There is myFUNC2. Same like myFUNC1, is one more function object is created. That is myFUNC2. Right. Like this, a function object gets created. Function object gets created. So float object is created. Function object gets created. Function objects are code objects. That's why they goes to code segment. Next, I am calling the function. From where actually we are calling function? So and so instruction. Already stack pointer is noted. Now you see from this instruction, so instruction pointer is noted. From which instruction actually the function called, function is got executed. Instruction pointer is noted. So we are calling my function 2. So for the my function 2 memory is required. It refers the stack pointer at the stack location. At the stack pointer it creates a function stack frame for my function 2, myFUNC2. myFUNC2, right? So memory is created for function 2. Okay. And the stack pointer location is changed. Now the stack pointer is a different location. So that stack pointer is noted. Now myFUNC2 execution begins. First print command, second print command, X and Y, local variables. So here if you see, 30 is the integer object, 20 is the integer object, right? So X is 20, Y is 30, 20 is the integer object. It occupies memory. This is memory object. 30 is the integer object. So actually in this function stack frame, we do have return instruction pointer. Return instruction pointer is nothing but after completion of execution of this function, where should we go back? To which instruction I have to go back? That is nothing but instruction pointer. After completion of instruction pointer, remaining statements will be executed. That is recorded here. And here x is a local variable, y is a local variable. These both are local variables here. It contains local variables. X references 20, y references 30, right? X references 20, y references 30. Now this is okay, this much execution is over. Here I am calling function 1. Here I am calling my function 1. So my function 1 execution begins. We are passing parameter 40. Okay. See, my function 1 execution begins. Function 2 execution is not yet completed. My function 1 execution begins. This is the instruction pointer. This is the actually stack pointer. At that stack pointer, it creates another function stack frame. So instruction pointer is recorded, stack pointer is referred, it creates the function stack frame for function 1, and a new stack pointer is recorded. This is the function stack frame for my func1. So function my func1 execution begins. Of course, it contains a return instruction pointer. The return instruction pointer. After successful completion of executing the function 1, to which instruction I have to go back? That is return instruction pointer. Here you see P1 is the parameter, that is local variable. Actually, the object is 40. 40 is the object. P1 is the parameter variable, reference variable. So P1 is referencing the 40. Okay. And X50, Y70. So 50 is an object, 70 is an object. X and Y both are local variables. X references this 50, Y references this 70. Okay, then here P1 is equal to P1 into 10, 400. The new object 400 is created in the memory. Now P1 is pointing this 400. Now P1 is pointing this 400. Now it is not pointing 40. Right? This is how now P1 becomes 400. Okay, then locals are printed, globals are printed, function 1 execution is completed. As soon function 1 execution is completed, function 1 memory resources are got cleared. Okay. So it will back to function 1 execution completed. It will back to where the instruction pointer. So remaining statement should be continued. So here locals are printed, globals are printed, function 2 execution completed. Whenever the function 2 execution is completed, function 2 memory resources are get cleared. Okay. So stack pointer is back. Based on the return instruction pointer, it will go back to where you are calling function 2. Then globals is executed, program execution is completed. So complete program memory layout gets cleared. This is program memory layout and the function stack frames. All of you clear about this memory model, this memory layout? So whenever you are working with functions with respect to this layout, you try to understand. Here allocating the memory, deallocating the memory for the functions, the memory allocation and deallocation scheme looks like stack. That's why it is known as stack frame. Just you observe this program. Here I have print command 9.8 G global variable. Here function 3. Here function 2. Here function 1. 1. This is main. Main is also a function. Don't confuse about the keyword main. It is nothing special. Just the name of the function is main. That's it. It's not having anything special. Whenever you are executing this program, what happens? First program memory layout is cleared. Global variable 9.8 created in the data segment. Then function 3 created, function 2 created, function 1 created, main created. These are the function objects created in the code segment. Then I am calling main. When you are calling main function execution begins. So here local variables are created, something is done inside the main. I am calling function 1. So it will create memory for the function 1, start executing function 1. Inside function 1, I am calling function 2. Start execution of function 2, memory created for function 2. Inside function 3, function 2, I am calling function 3. So function 3 execution starts. So first main memory is there, still function 1 memory is created, still function 2 memory is created, still function 3 memory is created. Now function 3 is over, so function 3 memory gets cleared, back to function 2, function 2 cleared, back to function 1, function 1 cleared, back to main, main is cleared, back to program. So program is clear. So this memory allocation scheme looks like a stack. Just you can observe that here. Memory allocation, deallocation. Wherever you see main starts here, that means memory is allocated. Main ends here, that means memory is deallocated. The memory deallocation is nothing but garbage collection. Here the function stack frames, memory allocation and deallocation mechanism is a stack mechanism. That's why they are called as a stack frames. Similarly, observe this program here. Function 9.8 is global variable G, function 3, function 2, function 1 main. But here I'm not calling function 1 in the main. I'm not calling function 2 in function 1 to function 1. I'm not calling function 3 in function 2, right? It is just a function 3 is a function object, function 2 is a function object, function 1 is a function object, main is a function object. Now I am calling main. Memory is allocated for the main is executed, main execution completed, memory deallocated. Then go for function 2. Function 2 execution, function 1 execution begins, memory is allocated, execution continued, execution completed, functions memory is cleared back to a return instruction pointer. Then function 2 I am calling. So function 2 execution begins. So memory is allocated, execution continue, execution completed, memory cleared back. Then calling function 3. So here these functions I am calling individually, they are independent. See, function 1 memory, main memory created, main memory clear. Function 1 memory created, function 1 memory clear. Function 2 memory created, cleared. Function 3 memory created and cleared. Finally, program memory is clear. This is how you can understand how memory is allocated and deallocated for the functions while execution for the sake of function execution. This is program memory layout and function stack frames. All of you clear? All of you comfortable about it? Any questions about this memory model, please ask me. I hope all of you good. Now let you see this. This is actually swapping two values. Swapping is very easy in Python. If you see other languages, that is different. Generally, if I take A is equal to 22, B is equal to 33, I want to swap A and B. I want to swap these values. So how can we do the swapping? Generally, we people know that either using third variable or using operation. A is equal to A plus B, A is equal to A minus B, B is equal to A minus B, like that. But here it is not like that. What is A value? 22. What is B value? 33. A comma B is equal to B comma A. Now what is A value? What is B value? Is swapping is done or not? Doing swapping is very easy in Python. Now look at this code. Swap two vals is a function. I am passing variable A, variable B, parameter variables. Inside the function body, I am performing swapping. This is my function. Here X is a variable, Y is a variable. I am calling swap two vals and passing X and Y. After completion of executing this swap two values function, is the XY swapping done or not? Is the swapping happens in between XY or not? Is X and Y get swapped or not? What do you guess? For that detailed observation only, I write this program. Actually, the default parameter passing mechanism in Python is call by reference mechanism. It's not actually passing the object or not passing the value. It is passing the reference of the object. Because in basic Python memory model is a variable is a reference variable. Variable is not owner of the memory. Parameter variable is also a variable. So it references, it passes the reference. Now you see 20 is the object actually. 20 is the object actually. Okay. And 30 is the object actually. Fine. 20 is having its own memory ID. 30 is having its own memory ID. Okay, fine. Now x is pointing 20. What is x? X is pointing 20. Y is pointing 30. Good. Okay, fine. Now what I am actually sending to parameter a, b, swap two values function. I'm a, b. X goes to a, y goes to b. X goes to a, y goes to b. So ultimately a is pointing the 20, b is pointing the 30. Understand? That we can print here and observe. I'm swapping between a and b. So a become this, b become this. Swapping happen between a and b, not x and y. X and y is as it is, right? This is due to call by reference. This is due to call by reference. Okay. Just observe memory IDs and everything. Object 20, what is the ID? What is object 30? What is the ID? So x is referencing 20, y is referencing 30. That we are passing as parameters. Then what is a? What is b? So ID of x and ID of a both are same. ID of y and ID of b both are same. After swapping, a and b get swapped internally. But outside x and y is as it is. Because it is call by reference mechanism. Call by reference mechanism. I hope all of you clear, all of you understand about call by reference mechanism. Let us understand one more program similarly. Look at this program. Modify is a function. It has parameter p. Okay. Then main is a function. Inside the main function, I am creating a list. L is local to the main. This is a list object. The list object is local to the main. Local to the main function. Okay. Just I am printing what is L, what is ID. And inside the main, I am calling the modify function. I'm calling the modify function and passing the list L. So L goes to modify. P is nothing but L. Now P of 1 is equal to 555. That is P of 1. So I'm doing this modification on the reference variable P, one indexed item I modified. My question is, after this modify, I'm printing L. Due to the modification, due to the modify function, is the L, original L, the list original L, get modified or not? Is it get affected? That is my question. Please try to understand. L is local variable. It is a list object. I'm passing that as a parameter to the modify. So L goes to P. So inside the modify function, I'm modifying P. Due to this, is the L get modified or not? If you run it and observe, yes, L is get modified. L is get modified. Why? Because if you see, L is local to the main. Okay. So here is 11, 0th index item reference is 11. Here is 22, one index item reference is 22. Here is 33, two index item reference is 33. This is L. L is reference variable pointing this object. Okay. This we are passing as a parameter to the modify function. P is local to the modify function. P is local to the modify function. What it is referring L. So P is also pointing the same object, right? So P of 1 is this one. We are modifying P of 1, we are modifying, that is 555. So 555. So one index item is modified, right? Understand? So ultimately L is also get modified, right? This is due to call by reference. This is due to call by reference. The by default parameter passing mechanism in the Python is call by reference mechanism. By default parameter passing mechanism in Python is a call by reference mechanism. Now look at this program, try to understand. You tell me, this time is the L get modified or not? I'm using modify function, same like previous program, but a little difference. You tell me the modification affected on the list L or not. What do you say, guys? Here, if you observe, for the P, I'm totally assigning a new list object. Now P is switched to new list object. Now P is referencing new list object. L is as it is. In this program, L is this one. L I am passing as a parameter. P references the same. Now I am assigning a new list to the P. P is now referencing new list object. So L is as it is due to call by reference. Now you look at this program. So call by reference is okay. The default parameter passing mechanism is call by reference mechanism. But how can I implement call by value? How can I implement call by value? Call by value mechanism you can implement. Call by value mechanism you can implement using a copy module. Copy module makes duplicate copy of the object. So the copy module, copy module dot copy method, it makes duplicate object, duplicate L. So now L is different. The another copy of the L is different object. So I'm not passing the L as it is to the parameter. I'm making a duplicate object. That duplicate object I'm sending. So L is different, P is different. So you are modifying P that not get affected into L, right? Just you observe. Here in the main, this is the L, this is the ID. What I am passing to modify duplicate of the L. So it is a different object, different ID. That's what we went to the modify function. After modification, the actually duplicate copy is modified. Original L is as it is. So using this copy module, copy method, we can make duplicate copy of the object. That duplicate copy we are passing as a parameter. This is how we can implement call by value. Call by value. Now you tell me. Now I am doing like this. So due to this modify, is the L get affected? Here I am using copy.copy. Please observe and tell me. Observe this program and tell me. What happens here? Is the L get modified or not? Once you run the program and observe, yes, L get modified. Why? Because the copy.copy module copies only that object, not the entire hierarchy of the objects. It copies only that object, not the entire hierarchy of the objects. Okay. So in this case, if it is multiple levels, hierarchy, what can I do? I can use copy.deep copy for implementation of the call by value. Copy.copy method makes only that particular object is duplicated. Copy.deep copy duplicates the entire hierarchy. Okay. This is copy.copy module, copy.deep copy module implementing call by value. By default is call by reference. This is about call by reference and call by value. I hope all of you understand by default call by reference and implementation of the call by value. All of you clearly understood. Next, let you observe this program. This is a recursive program, recursive function. What do you mean recursive function? The function calls itself is what a recursive function. The function calls itself is what known as a recursive function. See, inside the function body, this is the function I am writing for calculating factorial of the given number. FACTRL is the function name. FACTRL is the function name. Inside the function body, I'm calling the same function. If you observe carefully, this is recursive function, the function call itself. If I want to calculate a factorial of the 5, the given number 5, I'm calling the function. 5 is the parameter I'm passing. How this recursive function gets executed? Observe carefully. This is my recursive function. I'm calling the function, passing parameter is 5. So first time n value is 5. N value is 5. It returns 5 into, again calling the function 5 minus 1, 4. So here it is responsible to calculate factorial of 4. It is responsible to create factorial of 4. So next, again function stack frame. So this time n value is 4 and multiply with factorial of n minus 1, 3. Again it executes the function. This time n value is 3. Again calling the function. Three minus 1, 2. So here n value is 2. So again the function gets executed. There is n value 2 into factorial of n minus 1, 1. Again the function will be executed. Again the function will be executed. Here n value is 1. If the n value is greater than 1, then only this one, otherwise it returns 1. So factorial of 1, n value is 1. So it returns 1 simply. It returns 1 simply, right? So this function execution is completed. Here this factorial of 1 returns 1. That is 2 into 1. So actually this function returns 2 into 1. 2 into 1, 2 only. So this function execution is completed. Then factorial of 2 returns 2. So 3 into 2 now. So this function execution is completed. So factorial is 6 now, whatever the function returns. So now factorial of 4. Factorial of 4. So 4 into 6. So this function execution is also completed. Factorial of 4 is 24. Then factorial of 5 is 120. But this is how the recursive function, the function call itself is the recursive function. In Python, this is how we can implement recursive functions. So these are the main concepts of the function. Next, we have to go to the advanced concepts of the function, that is functional programming abilities. So function is an object. Function is an object. No doubt, function is a Python object. Then what is parameter? Parameter can be any Python object. So function also can be a parameter. What is return? Function returns any Python object. So function may return function also, right? Because function is also an object in Python. Function is a Python object. It is a code object. Okay. Now in this program, we try to understand that. Now you see, func is the function, it has some body, I am printing FUNC. I'm not calling the function FUNC. I'm printing FUNC. I'm printing what type of object it is, what is ID. Just run it. This is how. If I want to call the function, what can I do? If I want to call the function, what can I do? So here I am calling the function. Now look at this. This is just a reference variable. FUNC I am printing. Reference variable FUNC I am printing. Here I am calling the function. This is how to call the function. Here I am calling the function and gets the return value. Return. Got it? See, the function body is executed. I'm calling the function. This is how. Okay, this is the function object name, reference variable. Here I'm calling the function. This much you are understood very well. Now what I am doing here, FUNC, I'm assigning to X. What is FUNC? Function object. See, this is a function object. It has its own reference ID. FUNC references this particular function. Now that FUNC I'm assigning to X. X is also references the same function object or not. So X is nothing but FUNC function. If you are calling X, it will execute FUNC function. Run it and observe. Here what is X? X is FUNC function, nothing but this is a function object. X I am calling, so that executes the FUNC function. So X is also pointing the same reference, same function object. So function is an object. Calling the function executes the function. So X is a reference variable which is referencing the function object. So X is also a function object. I'm calling the X, it will execute the same function. It's just a basic understanding about your functional programming. Function as an object. Function is a Python object. I hope all of you comfortably understood about this. Now let us see next program. You observe this program. Greet is a function. FUNC is a function. Greet is a function object. FUNC is a function object that I am printing here. What is greet? What type of object it is? What is ID? What is FUNC? What type of object it is? What is ID? I am printing. This is the greet function. This is the FUNC function. Greet is a function object. FUNC is a function object. Now I'm calling the function FUNC. This FUNC takes a parameter. The greet function object I'm passing as a parameter. I'm passing a function as a parameter to the another function. Now, if you observe this, what is F? F is a function object greet. So inside the FUNC, I'm calling the function F. So greet function will be get executed. Now you run it, observe it. What is F? So this is the greet function. What is F? F is nothing but greet function. So I am calling the F. That means greet function is executed. So this is passing a function as a parameter to the another function. Inside the function body, you can call that, you can use that function object. Either you use reference or either you call it and execute it. Whatever way you want to do, you can do. This is function is a Python object. A function object you can pass as a parameter to the another function object. Okay. Now let you see another program. This is a nested function. Function inside the function is what nested function. This is the nested function. Carefully understand this. This is very important for the decorators. Further, for the decorators, this is very important. Okay. So here this is main program. This is the program. I is a variable, that is global variable. Okay, fine. Now FUNC is a function object. FUNC is a function object. Inside the function object, the local variable pi. Inside the FUNC function object, one more function definition, that is area. This is local to the FUNC. Area is the function object local to the FUNC. Okay. And moreover, if you see the function FUNC returns the area function. Area is a function object. It returns area function. So inside area function, of course, pi is global to area. This is accessible. So pi r square I am calculating, the area I am printing, and area I am returning. This is the function inside the function. This is nested function. This is what a function inside function. This is what nested function. Okay. Now observe carefully what happens if I call it. Now you see I am calling the function FUNC. Yes, I am calling the function FUNC. When I call the function FUNC, pi is defined, area object is created, and area is written. Now what is X now? X is referencing the area function object. What is X? X is area function object. If you observe carefully. What is X? X is a function local area. Area function object is X. Now I can pass parameter to the X and I can call it. So that means I'm calling the area function. Area is calculated. This is the area, right? So area function is executed here like this. Of course, for your better understanding, step by step in the multiple steps, I have shown you this. But actually, we can do like this, very simple. Very simple. FUNC. See, try to understand FUNC. Calling the function FUNC that returns area. Area of 5. Area function gets executed. Right? That's what I am doing here. So here FUNC function you are executing basically. The FUNC function executed, it returns area. So area function object is reference located here. That is nothing but area of 5. So nested function can be executed, right? This is a function within the function, nested function. And one more thing, function returns a function object. Function returns a function object. So function is a Python object. We can pass a function object as parameter to a function. We can return the function by a function, and nested functions. These all are advanced Python programming, functional programming related. Of course, this much all of you understand. This much all of you clear. All of you understood. Next, we continue discussing iterators, generators, decorators. So please confirm once all of you comfortable up to this functions chapter. Any questions, please ask me. All of you comfortably understand so far? Okay, I hope you are good. Now, let us understand. This is related to functions. Now, let us understand iterator object, generator object, and decorators. Iterators, generators, and decorators. Okay. Now you see iterators. Tell me output of this program. Tell me output of this program. All of you read this program, understand the program, tell me output. Of course, if you see the output here, for loop, first for loop get the 34 is the t value. S is 0. 0 plus 34 is greater than 100. No. So increment. Next to 40. 34 plus 40 is 74. Greater than 100. No. Next to 32. 74 plus 32 greater than 100. Break. So it reads this much and break is executed here. Okay, this is over. Next I am writing one more for loop. Here my question is, this second for loop again start from the beginning or it will continue from the 32 onwards. What happens? Can you tell me what happens in this case? What happens in this case? Now you see it will be continue from the beginning. Again it will begin from the beginning. This is second for loop. This is natural behavior. This is what naturally happens. But if you convert this as an iterator, this is the list object. Using iter function, I'm converting this list object as an iterator object. So if I convert a list into iterator object, I convert list into iterator object. This is list iterator. In case your object is tuple, if the tuple you converted into iterator, that is tuple iterator, range iterator, set iterator, like that. Anyhow, that object is converted into corresponding iterator object. Okay. Iterator object. Now ITL1 is iterator object. The same previous logic I'm doing now on the ITL1. S is 0. I'm iterating ITL1, printing the value and checking it. So first time 34 is the value. Next time 40, 34 plus 40, 74. Next time 32, it is greater than 100, break is executed. So this first for loop gives you 34, 40, 32, this much. So here the iterator object remembers the previous exit location or exit point. So next for loop will continue from there onwards. It's not again beginning from. This is iterator object. This is what iterator object. I hope all of you understand the iterator. I hope all of you understand the iterator. This is iterator object. It's very simple. Next, if you see generator object, next you see generator object. So look at this. If I write a function like this, if I write a function like this, I'm calling the function. Suppose this is my program. Suppose this is my program. Can you tell me what will be output of that program? Can you people tell me what will be the output of the program? If I write like this, the function. Hmm.
1 to 14 will be printed.
1 to 14 will be printed. Let us try. Okay, here return statement I gave in the loop. It will just print 1. That's all. Whenever the return statement executed, it will stop the function. It will exit from the function, right? So why 1 to 14 gets executed? Suppose here instead of return keyword, if I use yield, now it preserves those all values and finally make it generator object. Now you see X is generator object if you observe carefully. So return statement returns the value. That is the final step of the function. Function returns once the function execution is over. Okay, it will exit from the function. But here I am not using return keyword. I am using yield keyword. So 1, 2, 3, 4, 5, the series of values preserves, make it as a generator object. Now what function actually, what this function returns? This returns generator object. Generator object is iterable, so you can iterate it. Generator object is iterable, so you can iterate it using for loop. You look at this, the same code. The generator object is iterable, so you can iterate it. Got it? Now using this function, I'm able to generate the serial numbers 1 to 15 or not. Yes. Of course, not only this, you can use this way also. I'm calling the function 15 up to 15. So next x, generator function, if you use next, one by one value, you are able to access. This is what basic understanding about a generator object. I hope all of you understand what is generator object. I hope all of you understand what is generator object. See, look at this. You remembered the range function we was discussed, right? You remember the range function that we was discussed. Range function. Range function generates serial numbers in between the given range. There are 3 different syntaxes already we discussed. Here I am writing source code for the range function behavior. So I am creating my user defined function, my range. Here parameters I am taking arguments. If the length of the parameters are less than or equal to 3 and greater than or equal to 1, then only it is valid, otherwise invalid number of parameters error. So yes, if the condition begins, if the start is 0, step is 1. By default, starting with 0, by default, step is 1. If the number of parameters are only 1, the given parameter is end. If the number of parameters are 2, that is starting point and ending point. If the number of parameters are 3, that is starting point, ending point, and step. So here I am using while loop and iterating and generating the numbers, yield function. So now this function returns what? Generator object. Generator object is iterable. I'm iterating using the function. I'm iterating using the for loop, right? This is just for your understanding. An example, I am making source code for the range function, because range function already we understood. Okay. So here, this generator, using this generator facility, we can generate any sequence of the numbers, right? Suppose I want to generate Fibonacci series. So I want a series of Armstrong numbers in between given range. Okay. Like this, any series of numbers, if you want to generate, you can use this generator object. This is what about a generator. Iterators and generators. Functions chapter is done. And also you understood iterators and generators. Iterators and generators. Right? Next, we have to understand decorators. Next, we have to understand decorators. What is a decorator? Of course, decorator is a concept. Decorator is a concept. We have to understand it carefully. That is very much useful in further object-oriented programming also. This decorator concept is little important. So this we will discuss decorator. So next, comprehensions and map filter reduce. Decorators, comprehensions, map filter reduce. 1 second, give me a minute. So after this, we are going for comprehensions, map filter reduce. Then after, we have to begin object-oriented programming. So we will do one thing, guys. Today, you spend further time for practice the functions chapter. Okay, today I do stop here. You spend time for practice. Tomorrow I will discuss the decorators, and also I will discuss comprehension techniques, map filter reduce. Tomorrow I will discuss about it. Of course, if possible, I will teach you file IO. Tomorrow is Friday, right? Day after tomorrow, Saturday, I will discuss about serialization. So working with XML file, the binary, that is pickling, unpickling, working with XML files, working with the JSON files, those things we discuss day after tomorrow. Okay. So by this weekend, we'll complete this much. Monday onwards, I will begin object-oriented programming for you. Okay. So time is comfortable enough. So today, all of you, please spend your time for practicing functions. So you can comfortably, easily understand the decorators. Okay, guys. Okay, fine. So today we do stop here. Let us continue tomorrow. Okay, guys. Thank you. See you tomorrow then. Bye.